Hi, everybody. It's Professor Mitchell. Today we are looking at section 10.4, which is on adding, subtracting, and multiplying radical expressions. Our objectives are to add or subtract radical expressions and multiply radical expressions. And we're continuing with SLOB. All right, so adding or subtracting radical expressions is very similar to combining like terms. So in simpler, happier times, we did problems like 3x to the fifth plus 8x to the fifth. And that, of course, comes out to 11x to the fifth, right? So we just keep that, the term part the way it is. The exponent doesn't change. We just add the coefficients. All right, well, as you know now, a root is a type of exponent. For example, the cube root of x is the same thing as x to the 1/3. So I think it's reasonable then to say that 3x to the 1/3 plus 8x to the 1/3 has to be 11x to the 1/3. Now, I don't have any really good way of writing this with the text, so I think I'm going to have to try to. Okay, we're going to have to find the mouse, and I've got a cat in my lap. Okay. All right, so that is, whoops, let's try that again. That is the same thing as 11 times the cube root of x. So when you go to add and subtract radicals, as long as those radicals are exactly the same, it's just adding and subtracting the numbers in front of the radicals. All right, and radicals that are exactly the same are called like radicals. So they have to have the same index and the same radicand, which you remember is the expression under the radical. All right, so for our first batch of examples, we're going to do these two problems. 17 square root of x plus 8 square root of y minus 8 square root of x minus square root of y. And then we'll look at this second one, which is square root of 3 over 2 plus 4 square root of 3 over 3. Hang on, I'm having trouble finding my mouse again. All right, so for letter A, we have 17 square root of x plus 8 square root of y minus 8 square root of x minus square root of y. So the first thing I want to point out is that there are two pairs of like radicals here. There's 17 square root of x minus 8 square root of x. Those are like radicals. And then we also have 8 square root of y minus square root of y. So when I combine these two, remember you just do the operation on the coefficients. So that's going to give me 9 square root of x. And then 8 square root of y minus square root of y. Think of that as 8 square root of y minus 1 square root of y. That's going to give me 7 square root of y. Pretty easy, right? All right, that's the end of that one. All right, then we have square root of 3 over 2 plus 4 square root of 3 over 3. So this is really just this is almost more of a fraction problem than a radical problem. Remember, to add any fractions, you have to have a common denominator. So for these two fractions, that denominator would be 6, right? So to make the denominator 6, I'm going to do this one by 3 over 3, and I'm going to do the other one by 2 over 2. And that is going to give me 3 root 3 over 6 plus 8 root 3 over 6. All right, So now that they're both over 6, I just add the numerators. 3 root 3 plus 8 root 3 is just 11 root 3. So these two things add up to 11 root 3 over 6. All right, let's see what's next. Okay, so I call this unlike radicals, or are they? All right, so the first question, and I asked you something similar, I don't remember exactly when, a section or two ago. Is the square root of 9 plus the square root of 16 the same thing as the square root of 9 plus 16? If that operation was times or divide, the answer would be yes, but we've never asked this question before about addition. So pause the video and try that. See if they come out the same. When you're ready, come back and we'll compare notes. Okay. So the first thing I want to do is apologize a little bit for this template, this PowerPoint template. It's always bothered me that that looks like a negative sign. It's not, it's just a dash. And I cannot figure out how to change it in this template. All right. So just ignore that. If I want something to start, well, I don't use these bullets very often. All right, so it shouldn't be a problem. Square root of 9 plus square root of 16, of course, is 3 plus 4, which comes out to 7. And on the other hand, 9 plus 16 is 25. The square root of 25 is 5. So even though this did work for multiplication and division, it does not work for addition. And so it shouldn't be any surprise it won't work for subtraction either. All right, so the square root of a plus the square root of b does not give you the square root of a plus b. Okay, so in other words, when you're handed two unlike radicals and you want to add them together, it's not that simple. Okay, so sometimes it can't be done. You just have to leave it. Like if it said, well, if it was square root of a plus square root of b, you would just leave it like that. That's the simplest form of square root of a plus square root of b. However, sometimes radicals that look unlike are really like radicals. All right, so here are the examples we're going to be looking at next. And what all of these have in common is that once we have simplified the radicals like we did, again, a section or two ago, you will be able to combine these. They will turn into like radicals. All right, so switching back to the tablet. Let me get on the right page here. Okay. Now, since we have already covered simplifying radicals, I have to kind of assume at this point that you're an expert at that. So when I go to simplify the radicals, I am going to do it a little faster than I did when we were first learning it. As always, as you're listening and taking notes, if there's ever anything that I say that doesn't make sense, please write yourself a note in your notebook and then be sure to ask about it. Okay, you can email me, you can ask in the discussion boards. There's all different ways to ask. Okay, so the first thing I'm going to do, notice that none of these numbers, 75, 12, or 3, are perfect squares. However, the next best thing about 75 and 12 is that they have perfect square factors. I'm going to write 75 as 25 times 3. And I'm going to write 12 as 4 times 3. This one I'll just leave the way it is. That one is already in simplest form. Okay, so here comes the part where it goes a little faster. The square root of 25 times 3 is 5 square root of 3. The square root of 4 times 3 is 2 times the square root of 3. All right, and now those are all like radicals, so we just have to add and subtract the coefficients. Negative 5 plus 2 is negative 3. Negative 3 minus 3 is negative 6. So this is negative 6 root 3. All right, so 90% of this is simplifying the radicals. The new part of it's super easy, which is how it goes sometimes. All right, so this one looks a little more intense. Okay, just remember, separate the perfect squares from the leftovers. All right, starting with the square root of 4x to the 7th, y to the 5th. I am going to put my 4 over here. And then you remember how it works with the powers of x and y. Since we're doing square root, any even power of x or y will be a perfect square. So since those powers are both odd, I'm just going to take the power that's one smaller, x to the 6th, y to the 4th, and then the extra x and the extra y will go with the leftovers. Remember that? Okay, next we have 9x squared times the square root of x to the 3rd, y to the 5th. Same kind of thing. They're both odd powers. So I'm going to put x squared, y to the 4th with the perfect squares, and then xy will be a leftover. What you will notice in a lot of these problems is that you get the same leftover in every single radical, and that is not an accident. It's because the leftover part is going to be stuck inside the radical, and that's what's going to give you your like radical. All right, I'm running out of room here. Hopefully we'll be able to squeeze this in. Okay, same thing again. The perfect square part is x to the 4th, y to the 2nd. The leftover is x times y. Okay. So you take the square root of 4x to the 6th, y to the 4th, you get 2, x to the 3rd, y to the 2nd. And this thing is stuck inside the radical. Okay, now I have to be a little careful. 9x squared, that just gets carried along from the last step. And then the square root of x squared y to the 4th is xy squared. And don't forget that square root of xy. And then finally, 5xy times the square root of x to the 4th y squared, which is x squared y, and then square root of xy. All right, so now let's clean up some of the stuff that's sitting outside the radicals. I like this first one fine just the way it is, 2x to the 3rd y squared, square root of xy. And now, of course, when you multiply 9x squared times xy squared, you get 9x to the 3rd y squared. Ah, that's nice. Notice that everything about those two terms is the same except for the 2 and the 9, right? And I think that's also what's going to happen in this third term. 5xy times x squared y is 5x cubed y squared. All right. So the coefficients, we just add and subtract those. 2 plus 9 is 11. 11 minus 5 is 6. Everything else about those three terms is the same. So these terms combine into 6x to the 3rd y squared times the square root of y. All right. Next. And again, you know, I say it almost every other time, it feels like. Anytime you want to try one of these ahead of me, I totally encourage that. Pause the video, try it, come back and compare notes. If you decide to do that with this one, just notice they are cube roots. All right, so you have to remember how to simplify your cube roots. Okay, here we go. So the way that you simplify cube roots is you separate the perfect cubes from the leftovers. The perfect cube parts of 24x to the 3rd are 8 and x to the 3rd. Any power of x that is a multiple of 3 is going to be a perfect cube, which makes my leftover a 3. Okay, then over here, perfect cube factor of 81 is 27. And again, x to the third can go with the perfect cube. The leftover is 3. And then here we just have the leftover. All right, so let's break out those perfect cube factors. The cube root of 8x to the third is 2x. This is stuck inside. The cube root of 27x to the third is 3x. Cube root of 3 stuck inside. And then we have x, cube root of 3. All right, so now 6 times 2 is 12. 2 times 3 is 6. Everything about these three terms is the same except for the coefficients. 12 minus 6 is 6. 6 minus 1, there is an invisible 1 hiding right there, is 5. So that's going to give me 5x cube root of 3. All right, one more. The fourth root of 48 over 5x minus 2 times the fourth root of 3 over 10x. All right, so let's simplify those fourth roots. 48 is not a perfect fourth power, but it does have a factor that is a perfect fourth power. That's 16. So we'll write this as 16 times 3 over 5x. This one is fine just the way it is. Okay, the fourth root of 16 is 2. So we have 2 times the fourth root of 3 over 5x minus 2 times the fourth root of 3 over 10x. All right, so the only thing that's stopping me from being able to subtract those fractions is they don't have the same denominator. All right, so I'm going to address something that you may have noticed. This fraction could be simplified, right? There is a common factor 2 in the top and the bottom. So it would be perfectly fine to simplify that fraction. And as it happens, then your two fractions will have the same denominator. I am not going to do it that way, only because when you get to a homework problem that's like this, you may not be able to do that. So I want to show you the way that's going to work every time. Okay, and that would be to get a common denominator, which in this case would be 10x. I got to do the top and the bottom of this one by 2. And that is going to give me 4 times the fourth root of 3 over 10x minus 2 times the fourth root of 3 over 10x. They have the same denominator, which is 10x. 4 times the fourth root of 3 minus 2 times the fourth root of 3 is 2 times the fourth root of 3. So in the end, I end up having to simplify that fraction anyway, which will also not always happen. 2 divided by 2 is 1. 10 divided by 2 is 5. So the simplified form of this answer is fourth root of 3 over 5x. Uh-oh. And that'll take care of that example. All right, that brings us to multiplying radical expressions. Multiplying radical expressions is similar to multiplying polynomials. There is one thing that's going to come up again and again, and that is, what do you get when you multiply two square roots that are the same, like the square root of a times the square root of a? So there are probably at least a couple different ways to think about this. I decided to go with this one, and again, remember that is not a negative sign there. By the product rule for radicals, which we talked about, that was in the last section, I'm pretty sure. the square root of a times the square root of a is equal to the square root of a squared, because a times a is a squared. And as long as a is not negative, which we can assume it's not because otherwise these things would not be real numbers, the square root of a squared is just a. All right. So this is something that hopefully you will start doing automatically as you do more and more of these. The square root of a times the square root of a is just a. All right. Okay, so you'll see where that's going to come up in the next examples. All right, so let's look at those. All right, we're going to multiply and then simplify if possible. You see the problems right here. So let me bring that up on the tablet. And then I believe once we get through these, we are all done. All right, so first we have the square root of 5 times the square root of 15 minus the square root of 35. Notice that all three of these radicals are in simplest form. All right. So what I'm going to do is distribute square root of 5. And that is going to give me square root of 5 times square root of 15 minus square root of 5 times square root of 35. 5 times 15 is 75. So this is the square root of 75. And 5 times 35 is 175. So now something interesting happens. I started with radicals that were already in simplest form, square root of 5, square root of 15, square root of 35. I ended up with two radicals that can be simplified because 75 has a perfect square factor 25. And so does 175, right? It has a perfect square factor 25. All right. So when you simplify these, you end up with 5 square root of 3 minus 5 square root of 7. And that's how you would leave this answer. It turns out these are not like radicals, so they have to stay separate. All right. Next. Square root of 6 minus 4 square root of 2 times 3 square root of 6 plus square root of 2. Does this look like anything you've done before? I think it kind of looks like FOIL. FOIL. All right, so first would give me, let's write it like this, 3 times square root of 6 times square root of 6. Outer would be plus square root of 6 times square root of 2. Inner would be minus 4 times 3 is 12 times square root of 2 times square root of 6. And then last would be minus 4 times square root of 2 times square root of 2. All right, so you remember what I told you on the last slide? Important concept. Square root of a times square root of a is just a. So I'm going to use that here, and I'm also going to use it here. All right, so that's going to give me 3 times 6. The square root of 6 times the square root of 6 is just 6. Let's write this as square root of 12. This will be minus 12 square root of 12. And then this will be minus 4 times the square root of 2 times the square root of 2 is just 2. All right, we're getting there. I kind of feel like now writing this and this next to each other. And you know what? Let's just go ahead and say 3 times 6 is 18. 4 times 2 is 8. 18 minus 8 is 10. All right. And then Let's do this. We have 1 square root of 12 minus 12 square root of 12. That would give me minus 11 square root of 12. Is square root of 12 in simplest form? It is not. We can simplify that because 12 is 4 times 3. Bring out the 4, it becomes a 2. 11 times 2 is 22. And that is as far as you can go with that. 10 minus 22 times the square root of 3. You might be tempted to say, oh, that simplifies down to negative 12 square root of 3. Well, that would be like saying 10 minus 22x is negative 12x. That does not work. So again, you just have to leave it like that. All right, next. Square root of 3x plus 2 times the square root of 3x minus 2. So this would be a great one for you to try. Pause the video, try it, come back, we'll compare notes. All right. So you could FOIL this one, and if you did it that way, that's perfectly fine. I am going to do it slightly differently because I notice that there is a special pattern going on here. This fits the pattern A plus B. This fits the pattern A minus B. And what did we learn way back in the day about A plus B times A minus B? We learned that it multiplies to A squared minus B squared. So instead of foiling, there's a little shortcut. I'm going to write this as the square root of 3x squared, and then this will be 2 squared. All right, so what is this? What is the square of the square root of 3x? We should make that into another important concept. I'm going to write concept up here. Well, the square root of 3x squared is just another way of saying square root of 3x times square root of 3x. And that's the same concept that we had before. That would just be 3x. Okay. So understand that you are sometimes going to see it in this form, the square root squared. It's basically that the square and the square root just cancel each other out. So that comes out to A. Okay. This cancels with this. You can think of it that way if you want to. So this would simplify all the way down to 3x minus 4. And try to keep that one on the back burner. I have a feeling we might be seeing that again. All right, so here comes the last example for this section. We're going to find the square of the square root of x minus 6, subtract 7. All right, so I know, well, I shouldn't say I know. I suspect that you might want to kind of do a distributive thing where you square the square root and then square the 7. Unfortunately, that doesn't work. We can forget about that. You have to think of this as square root of x minus 6, subtract 7, times square root of x minus 6, subtract 7. And then FOIL it. That's probably the easiest way. All right, the square root of x minus 6 times the square root of x minus 6. What does that come out to? Doesn't that just come out to x minus 6? That would be another example of our important concept. Okay. The outer would be minus 7 square root of x minus 6. And the inner would be minus 7 square root of x minus 6. And then last would be negative 7 times negative 7, which is plus 49. All right, so I see 2 different pairs of things we can combine here. I see a negative 6 and a plus 49. And I also see a pair of -7 square root of x minus 6's. So when I put those together, the x is all by itself. -6 plus 49 is plus 43. And then -7 root x minus 6 minus 7 root x minus 6 is minus 14 root x minus 6. And since none of those three terms are like terms, this is going to be the simplest form of this answer. And that's going to do it for section 10.4. We'll see you next time.